looking at the fifth problem from the CODESPARK coding competition conducted by Codeyantra committee of Sri L.R. Tiwari College of Engineering. So let us look at the problem statement. Peter wants to host a magic show. For this, he found out that a special type of number exists for which if we keep taking out the sum of digits until we come down to a single digit, that single digit turns out as 1. Such numbers are called magic numbers. For example, we'll consider the number 325. On taking out the sum of digits, that is 3 plus 2 plus 5, we get 10. And on further taking out the sum of digits, that is 1 plus 0, we get 1. Though it would be a tedious task to check for every number if it is a magic number and he has a show in an hour. Write a program that would help him find all magic numbers between 1 and an upper limit n. So this upper limit n will be provided to us by the user, and we'll have to print all the magic numbers between 1 and the upper limit. So let us move on to understanding the approach with which we'll solve this problem statement. So I'll be explaining the solution in Java. The C++ code for the same will be displayed at the end of the video. Now let us look at the solution for this problem statement. I've already declared the main method and defined a function which will be checking if the passed parameter is a magic number or not. So in the main method, I have taken the input of our upper limit n and run a for loop from 1 to n. Now I'll write an if statement, that is if is magic I equals 1. If this condition will be true, I'll print the value of I. Now coming down to our function, which will test if the given parameter is a magic number or not. We'll be using two nested while loops to check if the number is a magic number. The outer while loop will run until the number is a single digit, that is, the number is greater than 9, and the inner while loop will give us the sum of digits of the whatever the current value of our number will be. So first of all, I'll initialize a variable for the sum and assign the value of 0 to it. And inside the inner while loop, I'll update the value of sum as sum plus equals num mod 10. So any number mod 10 will give you the last digit of that number. For example, 325 mod 10. So on division by 10, it will give you the remainder of 5, right? So you'll get the last digit, that is 5, on modulus of 10, taking the modulus of 10. And then we'll update the value of number as number equals num by 10. So 325 on division with 10, since num is an integer variable. So on division with 10, it will lose the last digit, that is 32.5. It will lose the last digit, that is 5, and you'll be left with 32. And then the loop will run for 32, then 3, and then the number will be 0. So it won't run anymore, and you'll get the final value for the sum of digits. Now we'll assign this sum to num. That is, the next iteration will be for the sum of digits. For example, our first iteration ran for 325, right? We got the sum as 10, and then we'll assign this 10 to our num. And on the second iteration, the while loop will run for 10. And then on the third iteration, the value of num will be 1, and the condition will not hold true. So the while loop will terminate, and you'll finally get the value of num. The function will return the value of num. I guess I made some error over here. Yeah. So this is the code for this problem statement. It was pretty simple. Now let's compile it and see if it will give us the correct output or not. I'll give the upper value as 50, and as you can see, we've got all the magic numbers between 1 and 50. So that was the solution of this problem statement. I hope you were able to understand. my explanation. If you have any query, you can ask in the comment section.